I think we're going to get started. So thank you everyone for joining. Today we have a special guest, actually, Kesha Williams. We will introduce her in a moment. Super excited. She's an Amazon, she's an ML hero, specifically machine learning hero. But real quick, wanted to just give a quick update. We do this monthly, and since the last time that we spoke, wanted to just remind everyone that we have this book that's coming out in early 2021. I think we're at about chapter 10 right now or so. It's going to be somewhere between 12 and maybe 14 chapters. So here's the link. Maybe Ansha can type the link into the chat there. And then off of this link, we have a link to the early release. So this is the O'Reilly website here with the early release table of contents. So while we've written about 10 chapters, the folks at the O'Reilly Media, they tend to release, I think, maybe one every few weeks to the public. So this is, like totally raw, unedited. We would love your specific feedback. There's actually a place if you find errors or find suggestions that you'd like to make, you could click on that link. And let's see, I think we actually have one or two. We have a sample one that I wrote, and looks like someone fixed one of our SQL queries, so super cool. And also, one thing that's cool is that we've opened up this book survey to actually, if you want to influence some of the content, we're pretty far into it by now, or maybe 2/3 of the book is done, but we do continue to revisit the survey results every couple weeks and see what people are looking for. So we actually made some pretty significant changes to the book very early on, where we decided to focus on natural language processing based on the survey feedback, made some other changes. We're focusing on TensorFlow, Keras, also adding a little bit of PyTorch. We cover scikit-learn. These are the top three that we were getting back. Also SparkML is in there. So yeah, let us know. You can optionally put in your email and get discount codes for the book, things like that. Also, quick reminder, this is the week where we do all of our workshops. So we actually have a workshop, full day workshop coming up on Saturday. It's free. You can get to all these links, by the way, by this original book website and sign up. This is full day. This is absolutely free. So this is hosted, or we are using Amazon servers. So each person gets their own account. These are temporary one-day accounts, and then we tear them down at the end. But full day going into pretty much everything here. This is the actual GitHub repo. We do a quick intro, then we cover automated ML with a product called Autopilot. Going all the way through human in the loop, we ingest data using Athena, Parquet, Redshift, TSV, CSV files. We explore the data using Matplotlib. We then prepare the data for training. We're using BERT and using TensorFlow TF record. So we convert CSVs into TF records. We then train the model using Keras on big clusters. We then do hyperparameter tuning. We then deploy the model and then build a complete pipeline from all of the previous steps. The last part of the day, we cover Kubeflow and actually build a full end-to-end Kubeflow pipeline, which is pretty cool. And we're starting to add more streaming. That's actually one of the extra chapters that we are deciding to add on based on feedback from readers. So I think that's it. If there's any questions, Ansha and I will be answering them. And I think we could take it back here. So yeah, Ansha, do you want to introduce Kesha?
Sure. So hi, everyone. Good morning, good afternoon, depending from where you're joining. So it is my absolute pleasure to introduce Kesha Williams. As Chris already mentioned, she's an AWS machine learning hero. But not only that, she's also an Alexa champion. She is an award-winning software engineer, machine learning practitioner, and a training architect at ACloudGuru. So apart from that, she also trained and mentored thousands of software developers across the US, Europe, and Asia, teaching at the university level. And I don't know where you find the time, Kesha, but she's also organizing the AWS Meetup in Atlanta and is also mentoring women in tech. So super excited. Thank you very much for joining us today. And Kesha will give a talk and a demo how to become a rock star with AWS DeepComposer. So I think we're going to hear some funky tunes there. And with that, please welcome Kesha. And Kesha, over to you.
Thank you. I am very thrilled to be here today with you all and really just share my lessons learned with DeepComposer. So let me share my screen. Can you guys see my screen?
Yes.
Wait a minute, I think I'm sharing the wrong one. Hold on. I want to share this one. Okay, let me. Do you see my slides?
Yes, we see the funky DeepComposer slide. Yep, perfect.
Okay, and you don't see my speaker notes, right? Just want to make sure.
Correct.
Okay, awesome. My name is Kesha Williams, and just let me start by telling you a story that ties in with DeepComposer. So, as a young girl, I played the piano, and that was a very long time ago. And I was actually good enough to play for the youth choir in church. And really, the only thing I remember, apart from playing for the youth choir, is having to wake up every Saturday morning and go to piano practice. And I literally missed every Saturday of cartoons. So back then, we didn't have stations that played cartoons around the clock. Cartoons only came on Saturday mornings. And so I'm still a bit bitter about that. But when I saw the DeepComposer, it really took me back to my childhood days, and it brought out the kid in me. So I'm going to share with you 4 of the AI-generated DeepComposer tracks that I created, just to give you an idea of what you can produce with DeepComposer. I've uploaded all of my tunes to SoundCloud. There's actually a DeepComposer playlist, and there are 9 tracks. So let me play this one, and it's inspired by one of my favorite reggae tunes, One Love by Bob Marley. So that's a reggae track. And as you can tell, I had fun giving it a creative name. So this process just really allowed me to be creative and have a lot of fun. So that was called Summer Breeze. And this one I called Deep Space. And this is actually a hip hop track. That definitely sounds like you're out in space somewhere. And then this one, I call it Cloud Life. Another hip hop track. And lastly, another hip hop track, I call it Higher Heights. You can see the staircase. Okay, so that just gives you an idea of what you can generate with DeepComposer. So quickly about me, I have been in IT for the last 25 years, mainly in a role of software engineering with a heavy focus on Java. And I've had several different titles: software engineer, web developer, tech lead, software engineering manager. And maybe about 3 years ago, I started just playing around and experimenting more with machine learning, because it was just this topic for me that was always complex and kind of scary. And so I told myself, you're in IT, you need to get in there and figure out what this is all about. And through my exploration and learning, I started sharing what I learned with others. And through that, I was lucky enough to be named an AWS Machine Learning Hero. And then also I play around a lot with Alexa and Alexa Champion. Currently, I serve as a training architect with a company called ACloudGuru. And we have a lot of online training courses that help people prepare for certifications. I recently released a new web series that's actually free around DeepComposer, and I'll share more about that later. So what are we going to talk about today? First, I'm going to give you an overview of DeepComposer. I'll introduce generative AI, and this project really actually allowed me to learn more about how that process works. I'll show you how to generate a very simple composition using the AWS DeepComposer console. And then the true power of DeepComposer is really training a custom genre model. So I'll walk you through that process and share some of my lessons learned. And then at the end, we'll have a Q&A. What is DeepComposer? And I was super excited when it was unveiled last year at reInvent. And it is a machine learning enabled keyboard. So just like those words alone, how can you not be excited about DeepComposer? So it's a machine learning enabled keyboard that allows you to generate music using generative AI. The keyboard connects to the service in the console, and I'll show you that process. And when I talk to my friends at AWS, they describe DeepComposer as an educational service. And that is so true, because using DeepComposer and just learning more about generative AI, it allowed me to learn a lot in a fun and interactive way. There are some advanced features that require you to have coding skills, but there are simple features where no coding is required, and you definitely don't need musical ability. Like I told you before, I played the piano many, many years ago. So how does the process work? First, you have this input melody. So you take the keyboard and you play your input. And if you don't have the physical keyboard, there's also a virtual keyboard in the console, and I'll show that to you. But you have this input melody, and then that melody is fed to a music genre model. And out of the box, DeepComposer comes with several pre-trained models. And the model takes that melody, and then it adds accompanying instruments based on what it's learned about that music genre. And then you have this final track. So now let's jump into the DeepComposer console. Trying to find my mouse. Where did it go? There we go. Okay. When you initially log into the console for DeepComposer, this is what you'll see. And there are several sections here on the left-hand side. Okay, I've lost my mouse again. There it goes. Bear with me. Here we have a music studio, and this is the most important piece, so I'll cover that last. Here you have models. So remember I mentioned that there are pre-trained models. So out of the box, you have 6 pre-trained models. Here this is actually a new one. One for Bach, jazz, Jonathan Colton, pop, rock, and symphony. So out of the box, you can generate music based on these genres. Then we have compositions. And this actually shows all of the music compositions that you've created. So I've been playing around a lot with it. As you can tell, it looks like jazz is my favorite. Learning capsules, these are like quick study guides that just teach you more about the process. So let's go to the music studio. This music studio, this is where you actually connect your DeepComposer keyboard. So down here you have this virtual keyboard, and I actually have my physical keyboard connected. So if I play on the keyboard, you could see that it's highlighting the notes and you hear it playing in the background. So the first step here is to, like, if you don't trust your musical ability to actually play a melody, and for me, I spent several days learning how to play different songs, like for example, the One Love melody by Bob Marley and some of the other hip hop melodies. I actually took time to learn how to play those on the keyboard, and that piece of it was fun. But if you don't trust your own musical ability, there are several sample melodies here that you can use to actually generate a song. So let's click on New World. I haven't heard this one. Let's click play. Okay. And so that is the melody that you're going to feed to the music genre model. The next step here, let's pick the Generative Adversarial Networks, or GANs. This autoregressive, that's actually something new that I haven't seen before. It looks like they're continuing to add new features to the DeepComposer console, which is pretty cool. I can't wait to check that out. So let's look at this GAN architecture. And there are two algorithms that you can choose from, MuseGAN or UNet. And so with MuseGAN, that architecture was actually created to train music. And then UNet, it's used a lot in computer vision. So I'll just stick with MuseGAN. And then here you select a model. And that's one of the pre-trained models that I told you about. So rock, pop, jazz, let's pick jazz. And then the next step is to click Generate Composition. And this one is usually fast. Yep, there we go. And so this blue line here, that's the input melody that was sent to the jazz genre model. And then that model added these three accompanying instruments. So this piano, bass, and drums. So let's click play to hear how this sounds. It sounds okay. At least it sounds like music. And here with the console, you can mute certain tracks. And then you can also change the accompanying instrument. So if you click on this, you can select a different piano. Let's say maybe the electric grand piano. And down here for the bass, you can pick something else. And for this example, you really have to be creative. You know, music is very subjective. And so I spent a lot of time experimenting with different instruments just to see how the sound would be and if it's something that I personally liked. So for me, this piece was really fun, just the experimentation and playing around. I also wanted to point out on this screen, this virtual keyboard down here. Notice it's showing the keyboard letters. So if you don't have the physical keyboard, you can also use your computer's keyboard to control it. Now for me, since I have the virtual keyboard, I changed the setting to disable hotkeys. And then when you do that, notice you see the letters that you have to play, or the notes that you have to play on the keyboard. Let's see, what else did I want to tell you? So the keyboard, it's $99, and with the free trial, the first 500 compositions that you create through this interface are free. So that's something to note, that you can play around for 500 compositions. Now let's go to compositions. And remember, I showed you, this is actually the list of everything that you've generated. When you go to a composition and you click on it and look at actions, there's a direct integration with SoundCloud. So it makes it really easy for you to upload your song to SoundCloud. So you just simply click on share on SoundCloud, or you can actually download it as a MIDI file. And I'll talk more about what that file type means. You can also download it as an MP3. And if you click load it into Music Studio, then it takes you to the Music Studio with that composition. Okay, so let's go back to the presentation. So that was a quick demo. So in that music studio, we saw rock, pop, symphony, jazz, and a few others. But what about other music types? For example, for me, I love reggae. And so the very first sample that I played you was inspired by Bob Marley, who is a pretty popular reggae singer. And what if you like hip hop, or what if you like country music? It's possible for you to train your own custom music genre model using generative AI. So let me talk about that process, and then I'll show you the code behind how you do that. The first step is to bring your own data files. And so for me, I had to spend time searching and sourcing royalty-free music files, specifically in the reggae genre. And the file format that you need is MIDI. So when I was first going through this process, I didn't realize that. And so I actually found some websites that sold music that you could use royalty-free. And unfortunately, I bought WAV files. So going into this, just know that you need MIDI files. And so you bring your data. So that's the training data, the data that you're going to use to train your music genre model. And actually, when you're dealing with generative AI, there are two models. First, you have this generator model. And the generator is responsible for actually producing the music. And then there's this discriminator model. Sometimes it's called the critic. And that model is actually responsible for evaluating the music. So the generator produces this deep fake reggae, and I call it a deep fake. And if you're not familiar with that term, if you're active a lot on social media, you'll see like fake videos of someone famous speaking, but what they're saying, like, it's something totally that person would not say. And that's a deep fake video, and it's generated by AI. And so this generator model is responsible for producing this deep fake reggae song. And the really cool thing is this deep fake, it's not an exact replica of the training data of what it was fed to learn from, but it's actually something brand new. And for me, that's what makes generative AI super exciting. And so that deep fake is then evaluated by the discriminator model or the critic. And so the discriminator model, really what it does, it critiques how far off this deep fake is from the original training files. And so you can think about the generator and the discriminator having a conversation like this. So the generator is going to say, hey, listen to this. And the discriminator is going to be like, he's going to say, dude, that sounds fake. Or he's going to be like, dude, that sounds really good. I can't even tell the difference. And so the discriminator gives that feedback to the generator. And if it sounds fake, the generator is unfortunately penalized, and that causes its weights to be adjusted. And then sometimes the discriminator reaches a point where the feedback that it provides isn't that great and it has to be retrained. But this process occurs for multiple iterations. And then at the end of this process, we have this generator model that is now used to generate music, and the discriminator model is thrown out. To actually create this music genre model, we'll use SageMaker. SageMaker, you can think of SageMaker as machine learning as a service. It gives you Jupyter notebooks, and that's how I will be using it, and also very powerful access to very powerful training instances, so access to GPUs. It also has model hosting. Okay, so now let's jump over to this process to train a custom music genre model. This notebook is freely available through the ACloudGuru DeepComposer series that I created. It's called AWS DeepComposer, Train It Again, Maestro. And the title for this series is very telling, because all I did was retrain this model over and over and over again until it was producing something that sounded halfway decent. And so, like I said, this is freely available out there on the ACloudGuru GitHub. So I'm going to walk you through what's going on here. In this initial cell, I'm just setting up the environment. A few important things to note. I'm using TensorFlow, and then piano roll, which is a library that allows you to work with music or MIDI files from within Python, and it's super, super helpful. Here in cell 2, I'm just doing some general imports and configuration. Cell 3, I'm just setting up the directory, so where my MIDI files are located, where I want to save the checkpoints and the music created during the training process, etc. So now let's talk about this MIDI file. I really had to go through a process of even understanding what this file contained and how it worked in order to get it in the proper format for training. And so here, whenever you use that piano roll library to work with MIDI files, you're going to create what's called a multi-track object. And like the name says, it's an object that contains multiple tracks. And so for one single MIDI file, that file can have different instrument tracks. And so this diagram is just really trying to show that. So there's a bass track, an organ track, clavinet, guitar, etc. There's also a tempo, and that tells how fast or how slow. There's the downbeat, the beat resolution, and the name. Now, one important thing to note with the network that we're using for training, it only supports 4 instruments. So that was another learning that I had, because initially, well, basically all of my MIDI files have more than 4 instruments. And so you need to have exactly 4 instruments, no more, no less. So if you don't have 4, you'll have to augment it somehow. And if you have more than 4, then you have to truncate it. And so I really had to just understand reggae music and pick out the 4 most popular instruments. And I'll show you how I did that. So within this multi-track object, you have these tracks. And let's take this base track and blow it up and understand what's actually going on within that base track. So within that base track, there's a name, and typically you'll see it's the name of the instrument. And then you'll have this program number. And this is very important. And I'll show you, I had to use this several places. This program number, each instrument has a unique identifier, and it's the same across all MIDI files, and it's really a standard. So there's this general MIDI specification. I'm going to scroll down. And you'll notice that within each instrument category, each instrument has a unique identifier. So for example, this electric piano 1, the unique identifier is 5. So this is the program number here within your track. There's also a flag that tells whether or not it's a drum. And then here, the most important piece is this piano roll. And so this piano roll basically has, it's like the notes or the sound and the pitch that actually make up the instrument sound. And so it's represented as a NumPy array, and it's the piano roll. So you'll have multiple, and that's what a track looks like. Here in cell 4, I'm just going through the process of really understanding my MIDI files. And so with machine learning, you really need to understand your data and what you're dealing with and how everything works. And so this cell, I'm just looping through all of the MIDI files that I've uploaded, and I'm determining the instruments across the tracks. And like I mentioned to you before, I can only pick 4. And so this just shows the instruments and their program numbers. And so now I have a really good understanding of my training data, the MIDI files. And so now I'm going to have to make some decisions. And in this is where I'm actually preparing the training data. And so you have your MIDI file. You're going to have to get these tracks, the piano rolls, and that's represented as NumPy arrays. And then you're going to have to take those piano rolls and then store them in your training file. And honestly, I'll tell you, I spent weeks and weeks trying to figure out how in the world did you take a MIDI file and convert it to the format that you need to convert it to for training. And honestly, for me, that was the hardest part of this process. Okay, and so here in cell 5, this is just a helper function that I call elsewhere, and it's called store track. And basically this is just taking the 4 instruments that I've selected. So in this case, for reggae, I selected the piano, all of the piano instruments, all of the organ instruments, all of the bass instruments, and all of the guitar instruments. So those are the only tracks I'm going to pull out of that MIDI file. And then everything else, all of the other instruments, I just throw them away. And so I'm just storing those tracks here in a collection, a dictionary. This is another helper function. So once I've picked out all of the tracks for the instruments that I care about, I'm going to have to take each piano roll in those tracks and reshape it to the proper format needed for training. And then I'm going to have to merge it. And so that's what this process is showing here. In this loop, I'm looping through all of the tracks from my chosen tracks. I am reshaping the piano rolls to be the proper format for training. And then once I have that, I'm taking those tracks per instrument and just concatenating, or you can think of it like stacking them on top of each other. And so now I have all of my merged piano rolls in the proper format for the 4 instruments that I care about. So that's what those two helper functions do. So in cell 7, this is the real heart of the program. And so here I'm looping through all of my MIDI files, just doing some extra checking to make sure I'm actually dealing with a MIDI file. And then here with music tracks, this will take that MIDI file and produce that multi-track object, that image that I showed you previously. And then I'm doing some just reshaping here, some padding to avoid some of the errors that I was seeing. And then here I'm calling the get merged function that I just told you about. That's getting the piano tracks merged into one. And then I'm adding it to this track list. And so track list is just what I defined up here, and it's going to hold the NumPy arrays that need to go into my training file. Then I'm just printing out some useful error, just some messaging. And what I realized with some of the MIDI files that I had, they couldn't be processed. And so, I mean, that's a part of machine learning and having data in the proper format. So I would say maybe 30% of the MIDI files that I was able to find for free, royalty free on the internet, I wasn't able to use due to errors. So that's just a part of the data pre-processing. And so here in cell 8, I'm just splitting the data for training and evaluation, and then I'm saving to the proper files. And so reggae-train, that is the training data that I will use to create the reggae genre model. In cell 9, I'm just reviewing the training data. So notice here, whenever you look at a piano roll, it really looks like images. And so oftentimes people will use that UNet algorithm that UNet architecture that I mentioned to you earlier, because these musical notes actually look like images. Okay. The next few cells, this is where I'm actually building the model architecture. And this section actually comes from a Lab 2 code provided by AWS. So they have gone into great detail explaining how you build the model architecture. And I just really leveraged that. And I made minor modifications. And so I'll show you where I've made changes. So when you all get to do this on your own, you'll know what exactly you need to change. And so the first thing I changed here makes sense. You have to load your data file. So whatever file you created with all of your training data, that's what you have to load. And then here, they're describing the model architecture. So remember I told you about the generator and the discriminator. In this case, they call the discriminator the critic. So sometimes we use that interchangeably. So here they're talking to you about the generator, and they're using this UNet architecture. You can tell it has the U shape. And then this is the code to actually set that up. I'm just going to skip over that. And then this is where the critic is defined and set up. And so now this code actually builds the training architecture. And then here, this is where you actually start. You set up the hyperparameters and you define everything you need for the training process. And so here it's setting up the loss function. Here, cell 17, the optimization technique. So all of this you can use as is, but when you get down to cell 21, yeah. So here, this is where you actually define the epochs or the number of iterations. In a real world scenario, you would probably want to do maybe 2,000, 3,000 iterations. For me, I chose 200 because I'm very particular about having a high SageMaker bill. I can tell you, the very first time that I used SageMaker, when I received my bill, I almost had a heart attack because my bill was way more than my monthly car note payment. And so just a lessons learned there. Of course, the more iterations you have, the longer the training is going to take, which means you're going to have a higher bill. So think about that. And so when you kick off the training process, I want to show you this graph here. Whenever you kick off the training process based on the number of iterations, you'll see in real time this graph update. And the red line is the discriminator or the critic loss, and the black line is the generator loss. And at some point, you want to see convergence there. And then I want to show you cell 26. So you'll just see here different graphs that kind of help you understand what was happening during the training process. But cell 26, so you can set this up to save the music that's produced at different iterations. And so, for example, here, I want to show you iteration 150. And so what I did, I was able to download this MIDI file and then open it in GarageBand. So let me show you that and let you listen to that. Okay. So this is what was produced. You'll notice that there are 4 tracks here with 4 different instruments. And let me play this. Okay, so that was produced at iteration 150. And when you're playing around with this, it's really easy for you to take that MIDI file, download it, and then play around with it. And for me, that was the piece that really brought out my creativity, and that piece was a lot of fun. So I can show you when some of the tricks or tips that you can use if you have GarageBand to just make it sound like awesome. And so let me show you this project. Okay. And so essentially what I did, if you notice, this is the iteration, the files for iteration 150. And so initially from that previous GarageBand project, you saw that there was like that blank space. And so I got rid of all of the blank spaces, and then I just duplicated the tracks. And then just like in the AWS console, where you can change the accompanying instruments, GarageBand allows you to do that as well. And so I changed out the initial instruments. I remember there was like pianos and other things like that. And so I changed it to these 4 here. And then I was able to add a drum track. I was able to change the tempo here. Initially, the tempo was set at 100, which is really fast. So I changed it to 75. And then here in GarageBand, you can change just how loud an instrument is playing in your track by using this slider. And so I did that for all of the different instruments. And that really allowed me to create a unique sound. So I'll play this one. And for me, I think I like how that sounds better. But like I said, music is so subjective. You just have to create something that you think sounds good. Now let me go back to this, because I want to point out cell 29. Okay. So this is where you actually run inference. And so you have this reggae genre model. And now, remember I told you, you have to feed in a melody. And so the melody that I have is One Love melody. I actually went to the DeepComposer console. I don't know if I'll be able to show it to you now. Yeah, so I went to the DeepComposer console. And what you can do if you need that input melody, you can play. And then you can download it. And when you download it, you're downloading this MIDI file that you can then upload to the Jupyter Notebook and use it to run inference. And so that's what I did. Now, remember I told you about those program numbers from this general MIDI specification. So here you're able to define the exact accompanying instruments that you want added to your MIDI file. And that's how you do it here. And you pass in the program numbers. So this is really specific to your data set. And so this is something that you would have to change. Now let's go back. So that was a quick look at generating a custom music genre model. Like I said before, all of the code is freely available through the ACloudGuru GitHub. So what's next? I mentioned that I created a DeepComposer web series. Let me play the trailer of it for you right quick. Are you the next Beyonce, Ed Sheeran, or Celine Dion in the making? Well, having an awesome music track is the very first step. Welcome to DeepComposer Train It Again Maestro. If you want to learn more about machine learning that powers the AWS DeepComposer keyboard, we literally get hands-on composing our first AI-generated music track. I show you how to bring your own data set to train your own custom music genre model, how to evaluate your model to ensure it's producing music that actually sounds good. There will be a head-to-head battle between two machine learning maestros. Okay, so maybe you might not reach Beyonce level status, but you'll definitely be a machine learning rock star by the time this series is over. So it's just a really fun series where I take you through AWS DeepComposer in more detail. We'll have 6 episodes. We just released the first episode maybe 2 weeks ago, and then we'll be releasing the next episode sometime this week. So definitely check that out. And like I said, it's free. And then you can also read this blog that I authored for the AWS Machine Learning blog. And I just really go through all of my lessons learned when bringing my own data to create that reggae music genre model. And so that's out there. There's a lot more detail in there that I didn't cover today. So I hope you find that helpful. Now it's time for Q&A. So let me stop sharing my screen.
Yeah, thanks, Kesha. That was great. We've got a few questions here, and then yeah, me and Ansha have a couple just fun questions to ask.
35 new messages. We're going to be here
yeah.
for a long time.
Yeah. Yeah, so I have it summarized here. So let me, someone asked, can you convert the WAV file to a MIDI file if you do make that mistake of buying the waves, or if you already have a bunch of waves?
Right, so I did that. initially was my first course of action to really correct that mistake, but I couldn't find any like software that would do it. And then just in researching and Googling, I heard a lot of people saying like it's not really a one-to-one translation when you have a WAV file and you're trying to produce this MIDI file, because I guess the MIDI file is produced and meant to be read by some type of computer software. And I just, based on my research and what I found, it was just going to really not come to a good end if I tried to take the WAV files. And so I just scratched that and found MIDI files.
Cool. Someone asked if there's a workaround to the 4-instrument limit.
Not with this GAN that we're using from the Lab 2 example. It only works with 4, and you have to have exactly 4. And when I pose that question, it really comes down to the cost and the amount of time it takes. So for example, if the machine had to learn 6 different instruments or 7 different instruments, it's that training process is going to be more costly and more complicated. And so just the GAN that's provided in that Lab 2, it only supports 4, but I'm sure there are others out there that support more than 4 instruments. Was a good question.
Gotcha. And yeah, how much did the actual training cost? Yeah, like, do you remember for that?
Yes. So
for just one of the samples.
Is this for, now if you're training using your own data set, then there's a fee to that. But if you're training using the provided data set from Amazon, the first, I believe it said the first 30 days is free, but typically in order to produce music that you like, you want to bring your own data and train your own model. And because for me, I made so many mistakes the very first time, my bill was like over $300. But lucky for you, I've shared all of my lessons learned. So right. You will Excellent. Not make those mistakes.
Awesome. Can the evaluator be used as a real instructor to teach you to play the piano?
I'm not sure I follow the question. So there's the generator and the discriminator.
The discriminator, I think is what they mean. Yeah.
Oh, okay. Yeah. The discriminator is thrown away. It's not used in the process to actually generate the music. So can you read the question again?
Yeah, maybe the person can restate it here. So let me keep moving. Let's see, I have a question. Can DeepComposer actually generate lyrics to match the generated music? Can we combine this with like a BERT model or something? Or
I haven't seen that, but that would be really, really cool.
Yeah, it kind of reminds me of when you generate captions maybe from an image.
Yeah. That would be next level. Then there's no reason. Yeah, there's
artists anymore.
Yeah, that would be next level to have. I think I've seen some examples where generative AI creates the music and the lyrics as well.
Okay, we have a question just came in. How easy would that be to transpose an octave or 2 higher?
Now, within the DeepComposer console, you're able to change the octave. And also on the DeepComposer keyboard, when you play the melody, you're able to change the octave. And that's the only examples of where I've seen the ability to change the octave.
How much data is required to retrain the model?
That is a good question. Typically, the more data you have, the better. Now, for me, I had in my original training data set of reggae files, I had, let's say, close to 100 MIDI files. And for me, that seemed to work. That seemed to produce music that actually sounded like music. And early on, I just remember initially the music that was produced, it really didn't sound that good. But as I added more MIDI files and I increased the iterations of training, the music sounded better and better.
Okay, and clarification came in. If the evaluator or the discriminator knows if a track is a deep fake, it looks to me that it can be used to determine how close you play a track.
Yeah, so the discriminator, it does, it looks, it takes a look or a listen at the deep fake to see how close it is to the original input training data. And that's the feedback that it gives to the generator.
Okay.
Yep.
One fun question for you. This is a little trivia about Bob Marley. What was his birth name? His actual birth given name?
Robert Nesta Marley.
Nesta, yeah, exactly. Which current reggae bands do you enjoy?
Oh, that's a good question. Okay. So there is like the typical reggae. I call it typical reggae, but it's more like the roots rock reggae. And then there's this more fast pace. It's called dance hall reggae. And so it's more, I guess, more hip. It's faster. And it's like what you would actually hear in a club and you would go dance to. And so I have my two favorite artists, Beanie Man. I know that's a funny sounding name. Beenie, Beanie Man. And then this one's going to sound even crazier, Bounty Killer. Okay. So these are like icons from dance hall reggae, and they just had maybe a week ago a versus battle. I don't know if you guys are familiar with the Instagram battles that have been going on through versus, but it's basically where you have two artists that kind of compete, that have been competing against each other their entire career, and they have like a 3-hour battle on Instagram. And so Beanie Man and Bounty Killer, they just had a versus battle, and it was epic. Like I've rewatched that like 10 times. But yeah, dance hall reggae is my thing.
Do you like country music?
Okay, so I can tell you, I don't know a lot of country artists, but
There you go.
I like, and I don't know if she's even producing music now, but Shania Twain, back in the day, I loved her music. So I listen to country.
If we could add a steel drum to a country song, would it make it reggae? Would that be? Yeah, that's a silly question.
I'd have to hear that.
Quick question about ACloudGuru. Like I said in the chat, I'm actually a huge fan. When I first joined Amazon, I went to get all my certifications, just kind of get them out of the way. And that was the only app that I used. I just went straight through. So I always wondered, right, so how long does it take to actually record one session? And then, let's say it's a 5 or 10 series session, like, is this over months? Does each one take like a day or a week?
Do you mean for example, with this DeepComposer web series? Are you talking about?
Correct.
Okay, yeah. So it really depends. For me, I took really 6 weeks for 6 episodes. And that included like the learning and the troubleshooting and finding the MIDI files. So it just really depends on the schedule. But for me, like all of the episodes, they're already recorded and we're just going to release them every 2 weeks. So it's like that DeepComposer project for me, I've checked it off the list and now I'm on to the next thing.
Cool. Yeah, what's the next thing? Can you tell us?
I'm working on something not as fun as DeepComposer. I don't think anything is as fun as DeepComposer. I'm working on security. So identity and access management. I'm working on a new identity and access management course. I'm going to make that fun. So
Yeah.
I am.
Okay. Yeah, Ansha, do you have any questions that you thought of?
I really enjoyed that, Kesha. Thanks so much. And I have to admit, I'm a big reggae fan as well. So I grew up actually in Germany with the German reggae as well. So Seed and Gentleman. So I'm not sure if you ever heard of them. Culture Candela, but also really, really good artist, and obviously big Bob Marley fan. So
Yeah.
I just maybe have a last question here. So I know you've played around with a couple of those AWS Deep devices, whether it's the camera, the keyboard now. So if you have like one wish, like for the next educational gadget to come out, so what would you like to see?
Oh, that's a good question. Huh.
We had a camera for the computer vision. There's the keyboard for the music generation, and we had the racing car for
Right, right.
the racer. So we're all curious what could be the next big thing, right?
Maybe, and I don't even know if this would be possible, but maybe staying in the same music theme, maybe a microphone that you sing into and you come out sounding like Beyonce. No, I don't know.
Try that out as well.
Deep microphone using AI, the world's first AI
Deep mic.
enabled microphone makes you sing in tune.
All right, perfect.
Awesome.
Thanks so much. Yeah.
Thank you. It was a lot of fun sharing my lessons learned.
Awesome. Yeah, so thanks everyone. Thanks for attending. We'll be posting this to, it's going to be youtube.pipeline.ai. That's the community portion of this meetup series. And we'll have Kesha on soon. We actually talked to her about 2 or 3 topics, and they're all very exciting. So maybe the next one might be her transition from Java into machine learning, or just sort of general pathway into software. Yes, any closing statements, Kesha?
Just thank you for allowing me to be here and just share my lessons learned. For me, it's just really important to share some of the mistakes that I've made, some of my wins, to just inspire people, to show people that technology is not as hard or as complicated as it may seem, and to just go out there and get your hands dirty, give it a try. If you don't have a DeepComposer keyboard, you can actually use that virtual keyboard to play the melody and generate songs, and then just import the MIDI file in GarageBand and have fun. So yeah, that's my parting words.
Excellent. All right, everyone, have a great day. And yeah, like talk next month. Thanks.
Thank you.